And at last we come to part 5 of 5 of NIEM Advanced Technical Concepts, and this section deals with extending the NIEM. How do you take the NIEM, add things to it, make it better? So let's jump right in. So why would you need to extend? That's sort of the first question, right? I mean, the NIEM is huge, ginormous, chock full of thousands of objects representing all sorts of concepts. Why would you need to extend the NIEM? Well, even so, it's still not complete. And there's 3 general areas of incompleteness. Number 1, some concepts are local in nature. For example, a lot of code tables. You might have a local code table for some local jurisdiction. And there's really no reason for concepts which are local in nature to be part of a national information exchange model. After all, if we put every little code table from every little locality in the whole country into the NIEM, well, the NIEM would be even more unwieldy than it already is. So some concepts are just local in nature, and there's no sense in putting them in a national model. Some concepts are from a domain not yet part of the NIEM. And you saw this a lot in earlier versions of the NIEM. For example, earlier versions of the NIEM did not have anything regarding children, youth, or family services. So a lot of the concepts were either maybe in place in a different domain, but maybe done incorrectly because that domain was not a subject matter expert in the missing information, or else it was just not there. Some of the stuff that you'll see missing today is health and human services, which is becoming involved in the NIEM, but doesn't yet have a domain of its own in the latest release of the NIEM. So that's another reason. And then the third reason? Well, some things simply get missed. After all, the people who put the NIEM together are merely humans, and we all make mistakes. So some things just simply slip by. Nobody realizes it until later on people slap themselves in the head and go, why isn't X in this model? And the thing is, nobody thought of it at the time. Yeah, it should be, but nobody thought of it. So for all those reasons, there are things that are still missing from the NIEM. So you need to extend it to add those things. So let's look a little bit at the process of extending the NIEM. So how generally do you extend the NIEM? Well, the idea is, in general, to specialize from existing NIEM objects. First of all, that's kind of required to ensure that the infrastructure elements are available so that you can use the IDs and the refs and the metadata links. And to do that, you need to specialize from existing NIEM objects. When you're making data objects, things that hold strings, numbers, dates like that, you want to use the NIEM's version of those data objects. And it has it for nearly everything. So, if you're doing a string, you want to use NIEM's text type. You don't want to go directly to one of the string data types in XML schema. Same for dates. Use date type for that. That's why it's there. The only exception in the NIEM itself is Booleans. Boolean is the only time where you directly use NIEM-XSD Boolean for that. You don't use some Boolean or some indicator type or something like that. But for everything else, for numbers, for integers, for reals, for strings, for dates, use the built-in NIEM data objects for those. The next point is to extend from similar conceptual objects. If you're not doing a data object, if you're doing some sort of container that holds other elements, look for something simple and build off of that. Don't always start from scratch building a brand new object. Usually you don't need to. Usually there's something similar in the NIEM and you can use parts of it and then add only the things you need. And then finally, if you do need to start with a new container, make sure you use complex object type as your base, because that way you'll be ensured that you get all the infrastructure pieces that you need for your stuff to play well with the rest of the NIEM elements that are there. The mechanics of extending, well, basically you do it just like the NIEM does, and we've seen plenty of examples of that now. You choose a base type, you extend from that base type, making a new complex type, extend from the base type, and then add the new elements that you want. Now those new elements can be other existing NIEM elements where there's something in the NIEM, it's just not inside of the thing in which you need it inside. They can be brand new elements that you previously created, and you can use more than just the sequence tag. The sequence tag in XML schema says, well, here are the elements we're going to use and here's the order they're going to be in. And it's called a compositor. There are other ways to composite together elements in XML schema. Now the NIEM doesn't use them, but many of them are still legal. One is choice, where instead of sequence you have choice tags, and it says basically you have the choice of using any of these elements listed. Just one of them, but one of the ones listed. And there are some other compositors as well. You'd want to refer to XML schema, dedicated XML schema training to really get a handle on all of these. Here's a flowchart to help navigating the different choices you make when extending. For each thing you think you might need to extend, you go through this flowchart. At the start you go, well, for the concept I want to show, is there an appropriate NIEM element available? If there is, then use it. Don't make your own, and that's really a general golden rule for the NIEM. If there's something you need and it's in the NIEM, use it out of the NIEM. Don't go making your own if it's already there. That makes sense. So if there's already that element there, use it. If not, then you get to a second question. What will this element you need hold? Well, if the answer is other elements, then we continue down. And we look for an existing element. Is the thing you need similar to something already in the NIEM? If yes, then extend from that similar element. Use that similar element as a base and add the new things you need to it to make it just what you need. If there is no similar element, then you have to create your own brand new one from complex object type. And you'll start out with a blank container and then add the things that you need. Now let's go up a little bit back to the what will it hold. If instead of other elements it holds data, then we got to figure out what kind of data. Is it enumerated data? You know, a bunch of codes? Well, then you want to create a code table. If it's not enumerated data, well, then we shift over one more to the right and we say, what kind of data is it? Well, if it's numbers, then we head down and say, what kind of numbers? Integers? Well, then create a new object using integer type. The NIEM has one there for integers. There's also ones for non-negative integers, things like that, so that you can make whatever kind of integer you want. Is it something else? Is it a real number? Well, that's okay too, because the NIEM has a numeric type. So make your new element using that numeric type. So there you go. If instead of numbers you're talking about text, then the question is, what kind of text? Is it dates? And you're going, dates? Dates are text? Well, yeah, dates are text, right? If I say November 1st, that's a string of text, right? So in that case, for dates, you're going to want to use date type. If it's a true-false value, again, in XML, Booleans are just the words true or false. Well, if it's a true-false value, then you're going to want to use NIEM XSD Boolean as the type for your new element. And if it's just text, then you're going to want to use the NIEM's text type. So you want to follow this thought procedure every time you make a new element for the NIEM. And each and every time, you'll figure out what it's going to hold and exactly what it needs to look like. So we talked a little bit about extending, right? And it's not that hard. We've seen it all the time in existing NIEM elements. We've seen plenty of schema examples, and they all involve taking some base type and extending it to add new stuff. The trick is inserting it into your work. Sometimes that can be hard, sometimes it can be easy. Now, your information exchange, if what you're adding is a top-level object, and now remember back to the diagram showing instead of a deep hierarchy, the NIEM is a bunch of peer-level objects linked with relationships. If what you're creating is one of those peer-level objects way up at the top, just right under the root element, well, then it's easy. You just make the object. And when you define that root element, which is a subject for a different series of presentations, you'll just put your top-level objects in your wrapping root element. So that case is not a problem. But if you're trying to insert objects inside of other existing NIEM objects, well, then that requires more work on your part. So let's take a look at some of the methods for doing that. There are 3 methods for inserting objects into other stuff in the NIEM. The first is implied substitution. It utilizes implied substitution groups by turning an existing object into a substitution group head instead. The second method is called concrete extension. That's where you redefine an enclosing object so it can hold your new object, and then you redefine the object that encloses it, and you redefine the object that encloses it until you hit the root. And the third is called dynamic type substitution. In this case, you change the type of an enclosing object at runtime in the instance document, changing it from the existing type that it had to the new type that you made that contains the new stuff you have. To compare and contrast these 3 methods, we're going to use one example, and we're going to repeat that example 3 times, once in each method. Now, the example I like to use is called the Iberian secondary surname example. Here's the idea. Individuals from Spanish-speaking countries often have 2 surnames. One is the surname, and the other is the secondary surname. Now, one comes from the father's side, and one comes from the mother's side. Now, which one is which depends on precisely which country you're in. For our purposes, we'll just stick with surname and secondary surname and not care exactly where they came from. Now, you see the former president of Mexico's name down there, and I'm not going to try to say it because while I can say Norwegian names perfectly accurately, I have absolutely no clue in other cultures. So I'm not even going to try because I'll assuredly get it wrong. But in any case, the one that I can pronounce correctly is Fox, and that's actually the surname. That's not a middle name, that's a surname, and then the last part is a secondary surname. So this isn't a first and middle last name situation. This is a surname and a secondary surname. Now the thing is, the NIEM doesn't have a secondary surname. It has a person's surname, but it doesn't have a person's secondary surname. So we need to add one. But that secondary surname is not some root level peer object. It goes inside of a person name. So we need to figure out, how do we get that secondary surname inside of a person name, which in turn is inside of a person? Well, let's find out. With implied substitution group methodology, here's what we do. We make a new person name type by using person name type out of NIEM core as our base and extending it, adding a person's secondary surname. Now, of course, the person's secondary surname is going to be of the same person name type that all the chunks of the name are. So that part isn't hard. It's getting it inside the person name. So we'll make a new person name type, extending the old person name type in NIEM core, add the person's secondary surname. Then the trick is, we'll take our new person name element of this type, we'll make a new one, we'll make it of our new person name type, and we'll set its substitution group head to NIEM core's person name. Now previously, NIEM core's person name was not the head of a substitution group, but remember back to substitution groups. Substitution group members determine the head, not the other way around. So there's no problem with taking our new person name element and saying, hey, its substitution head is person name, and now suddenly we can replace person name wherever we find it with our new person name. Let's take a look at this in schema. So here's how it looks in schema. What we've done is we made a new complex type. We called it Iberian person name types, just so we know that, hey, this is our new Iberian person name. We based it on NIEM core's person name type. So things of this new Iberian person name type will have the same first, middle, and last names as any name of person name type has. But we've added the person's secondary surname there. And then at the bottom, you'll see our new elements, our new person name element. This is of our new Iberian person name type. And look at that. It's got a substitution group head of NIEM core person name. That suddenly makes NIEM core person name into a substitution group head and allows us to substitute the person name in for it. Now you'll remember a caveat, I hope, with implied substitution groups, and that is, if it's not an explicit group head, if it's a group head that has a type and can hold data, substitution group members substitutable for it have to be of the same type or a type derived from the same type. So it has to be the same kind of stuff, and that's perfectly fine in this case, because indeed our new person name is of a type derived from person name type, which is the type of NIEM core's person name. So that'll works fine. All that really means is you can't arbitrarily substitute things in, but it's okay because the things you're going to likely substitute in this way are going to be similar to what you're substituting in, so it all works out. And then the last element there is our person's secondary surname of NIEM core's person name text type. And now let's look at the instance. The instance starts with a person tag, person object. Inside of there is a person name. And inside of there is the person given name, surname, secondary surname. Ha! Look at that, we have a secondary surname. Now let's take a look at what things are extended. What things have been made new here? Well, we see person name is extended. We needed to make a new person name element to be of our new person name type. And then there's the person's secondary surname. That's new as well. Now I'm counting the number of extended objects because that's kind of important. Having lots and lots and lots of extended objects can be a royal pain, so we kind of want to minimize those where we can. In this case, we do it twice, a new person name and a new person's secondary surname. But here we have our new person name with the secondary surname added in, just what we wanted.